Hello students, let's go for the next model, that is Fourier transform. The name of the model is Fourier transforms. Okay, let's now have the introduction about Fourier transforms. Fourier transform is a technique employed to solve ODE, that is ordinary differential equations, PDE, partial differential equations, IVPs, that is initial value problems, BVP, that is boundary value problems, and integral equations. That means you already know many methods to solve these all types of problems. That is, these are all nothing but types of differential equations. You already know many methods to solve differential equation. This is one more method to solve differential equations. Means if whatever you know the known methods, if it is not possible to find the value of a differential equation, we are going to use Fourier transform to solve differential equation. Let's have the definition of this one. The infinite Fourier transform or a Fourier transform. Fourier transform is also called infinite Fourier transform of a real valued function f of x is defined by Fourier transform. This is f of x means Fourier transform of f of x, that is equals to integration minus infinity to infinity f of x into e to the power iu x into dx, that is equals to f of u. F of u is nothing but Fourier transform in the variable u, or Fourier transform of f of x, that is equals to integration minus infinity to infinity f of x into e to the power iu x into dx. This is the definition of Fourier transform. Definition of Fourier transform. This is also called complex Fourier transform. Complex Fourier transform is, here you can answer there is a complex term is there. Therefore, this is also called complex Fourier transform. Next, the inverse Fourier transform. Inverse Fourier transform is given by f inverse, that is inverse Fourier transform of f of u, or inverse Fourier transform of f cap of u, that is equals to 1 upon 2 pi integration minus infinity to infinity f of u into e to the power minus iu x into du, which is equals to f of x. Here we are integrating this one with respect to x. Here we are integrating with respect to u. Here you can see there are two variables are there. While solving problems of Fourier transform, we are integrating the function with respect to x. When we are solving problems using inverse Fourier transform, we are integrating the function with respect to u. Next, we have the types of Fourier transform. Here, one is Fourier cosine transform, another one is Fourier sine transforms. So, along with that, we have inverse Fourier cosine transform, inverse Fourier sine transform. If f of x is defined for all positive values of x, we define first one Fourier cosine transform. The definition of Fourier cosine transform is given by FC. FC means Fourier cosine transform of f of x, that is equals to integration 0 to infinity f of x into cos ux dx, that is equals to integration Fourier cosine transform of u. Fourier cosine transform is nothing but this is the definition for Fourier cosine transform. Along with that, we define inverse Fourier cosine transform also. It is given by f of x equals to 2 by pi integration 0 to infinity Fourier cosine transform of u, that is equals to cos u into d. Next, second one Fourier sine transform. Fs means Fourier sine transform of f of x equals to integration 0 to infinity f of x into sin ux dx, that is equals to fs of u. Fs of u is nothing but Fourier sine transform of u. u is nothing but a function here. Next, inverse Fourier sine transform. That is f of x is equals to 2 by pi integration 0 to infinity fs of u into sin ux into du. These are definitions of Fourier sine and cosine transforms and inverse Fourier and cosine and sine transform. This is the definition of Fourier sine transform. Fourier transform, that is integration minus infinity to infinity. Therefore, it is also called infinite Fourier transform. F of x into e to the power I u x into dx is equal to f of u, and inverse Fourier transform is given by 1 upon 2 pi into minus infinity to infinity f of u into e to the power I u x into du is equal to f of x. These are the definitions of Fourier transforms and Fourier sine and cosine transform. Next, here we have some important notes which we are using to solve the problems. E to the power ix is equal to cos x plus I sin x. This you know that is a complex number in exponential form. E to the power minus ix can be written as cos x minus I sin x. Next, if we add these two, e to the power ix plus e to the power minus ix, we are going to get here these two get cancels. Cos x plus cos x is 2 cos x. Next, after subtraction, that is e to the power ix minus e to the power minus ix is equals to. Next, what it becomes here, cos x and cos x get cancels. We are getting 2i into sin x. This is all about introduction and definition of Fourier transforms. Next, we'll solve the problems. Let's go for the problem. Let's solve this one. Find the complex Fourier transform of the function f of x equals to x for in the x mod x less than or equals to alpha. Second function is 0, here mod x greater than alpha, where alpha is a positive constant. Here we are asking to find the Fourier transform for the given function f of x. Here we can see there are two functions are there. One is x and another one is 0. One is x and another one is 0. Let f of u. F of u is, let us consider the definition of a Fourier transform, that is minus infinity to infinity minus infinity to infinity f of x into e to the power iux dx. F of x into e to the power iux into dx. Right? This is what definition of a Fourier transform. Now you can observe there are two functions are there. F of x, that is x and 0 are there. Now which one you need to consider? Okay. Let us consider f of x equals to x by data. By the given data you can write f of x is equals to x. We are considering f of x equals to x because here the interval is mod x less than or equals to alpha. Means we can have the limits from minus alpha to plus alpha. Interval is minus alpha to alpha. By taking this interval, we can solve the, we can find the Fourier transform. Let us take now the limits are minus alpha to alpha. F of x is x into e to the power iux into dx. This is what, by substituting given f of x we have written, and the limits. Now you can observe we need to integrate the given function. Whatever we have that function we need to integrate. Here you can see there is a product term is there. Product form is there, right? X into e to the power iux. So to integrate this function we need to apply Bernoulli's rule. Applying Bernoulli's rule on both sides. Applying Bernoulli's rule on both sides, that is integration of u into v dx. U is, that is equals to u into integration of v dx minus derivative of q double integration of v with respect to x plus second derivative of q triple integration of v with respect to x. This is what the Bernoulli's rule. Using this Bernoulli's rule, we are going to integrate this one. Therefore, f of u, that is equals to integration minus, okay, now we are integrating. Let us integrate this one, u. What is u term here? This is u, this is v. U into, that is x into, integration of e to the power iux into dx. Next, u dash means derivative of x, dy dx of x. Next, second integration of v, that is integration of first time integration of v into dx. Next, if you differentiate this one, if you are getting constant term, then leave up to second integral only. If we are getting any another x term, then go for the further integration term. Now you can observe integration of differentiation of x. If you differentiate this term, if you are getting constant term, stop up to here only. If you are getting another function x term, then go for the next integration term. Now if you differentiate x, we are going to get 1 only, that is constant term. So leave up to here. That is equal to x into integration of e to the power iux is e to the power iux upon iu. This is like what? Integration of e to the power ax into dx. That is equals to e to the power ax upon a. Right? E to the power ax into dx is e to the power ax upon a. That is e to the power iux upon iu. Between the limits, okay, minus alpha to alpha it is. Between the limits minus alpha to alpha minus derivative of x is 1. Double integration of first one time integration we have did here. Integration of p into dx, that already we know here. That is what? E to the power iux upon iu into dx. The limits are minus alpha to alpha. Here two terms are there, therefore I have written the limits separately. Next, this is equals to x into, here you can see 1 upon iu is a constant term, just writing outside. The function term is x into e to the power iux, just applying the limits only for the function term. Next, to integrate, you can see 1 upon iu is a constant term is there. Taking 1 upon iu outside the integration, integrating only this term. Integrating only this term, this we are getting into e to the power iux upon iu. The limits are minus alpha to alpha. Okay. Next, 1 upon iu. Now substitute the limits here. Alpha. Wherever x is there, substitute upper limit alpha, lower limit minus alpha. Substitute upper limit plus alpha, lower limit minus alpha. Okay. Alpha into e to the power iu alpha minus lower limit minus alpha into e to the power iu minus alpha. Right? Wherever x is there, you need to substitute the limits. Next, minus 1 upon iu into 1 upon iu. 1 upon I square u square. We left with e to the power iux minus alpha to alpha. For second term, still we are not substituting the limits. 1 upon iu into bracket alpha into e to the power iu alpha minus into minus plus alpha into e to the power minus iu alpha. Right? Next, minus 1 upon I square u square into bracket e to the power iu alpha, upper limit alpha, lower limit minus alpha, iu of minus alpha. Next is equal to 1 upon iu alpha. here you can see in the first term in bracket alpha is a constant term. Taking alpha as a constant term, e to the power iu alpha plus e to the power minus iu alpha. Next minus 1 upon I square u square e to the power iu alpha minus e to the power minus iu alpha. This is not just we have integrated and substituted the limits. After simplifying here we have obtained these results. But this is not our required answer. This is not the required answer. Okay. Now we know that here we are going to simplify the complex number like this. The value of 1 by I, that is equals to this we can simplify by multiplying I and dividing by I. Before that one, then we will get a clear idea about it. We know that I square is equals to minus 1. We know that I square is equals to minus 1 and 1 by I. Now I am going to find the value of 1 by I. For this 1 by I am multiplying and dividing by I. That is equals to I into 1I upon I into I square. And we just now I have written the value of I square is minus 1. This complex number, you know that I square value is minus 1, which is equals to minus I. The value of I 1 by I is equals to minus I, and the value of I square is equals to minus 1. Next, now you can see there is a complex numbers are there in the exponential form. This you can write it as e to the power iu alpha. You can write it as cos u alpha plus I sin u alpha. Cos u alpha plus I sin u alpha, and e to the power minus iu alpha, that is equals to cos u alpha minus I sin u alpha. Now adding these two, that is e to the power iu alpha plus e to the power minus iu alpha, that is equals to cos u alpha plus I sin u alpha plus cos u alpha minus I sin u alpha. Then adding LHS terms, adding RHS terms. Now here you can see plus I sin u alpha minus I sin u alpha, here cancels. The value of e to the power iu alpha plus e to the power minus iu alpha, here we are getting cos u alpha plus cos u alpha, that is 2 cos u alpha. Right? After adding these two terms, we are going to get 2 cos u alpha. Next, subtracting. Subtracting e to the power iu alpha minus e to the power minus iu alpha. Write down the expressions for this one, that is cos u alpha minus plus I sin u alpha. Next minus is there, therefore put it in a bracket, cos u alpha minus I sin u alpha, that is equal to cos u alpha plus I sin u alpha minus, multiply minus to the bracket terms, that is minus cos u alpha minus into minus plus I sin u alpha. Now here cos u alpha minus cos u alpha get cancelled, plus I sin u alpha plus I sin u alpha is there, that is equals to 2I sin u alpha. E to the power iu alpha minus e to the power minus iu alpha. Now using these results, okay, let me call this as equation 1. Using these results in equation 1, applying and substituting in equation 1, that equation 1 becomes, therefore equation 1 becomes f of u, that is equals to 1 by I means, now we know that 1 by I is nothing but minus I upon U into bracket, alpha is there, no? Minus I alpha into bracket e to the power I U alpha plus e to the power minus I U alpha. It is nothing but 2 cos U alpha. Next, 1 upon I square U square means 1 upon I square is minus 1 into U square. E to the power I U alpha minus e to the power minus I U alpha is nothing but 2I sin U alpha. Next, this is equals to, let us simplify this one, minus I alpha upon U, 2 cos U alpha, minus into minus plus 1 upon U square, 2I sin U, 2I sin U alpha. Again you can see there is a common terms in that equation. What are those common terms here? 2I. Okay, 2I is a common term. Taking 2I as a common term here, 2I into 2I I have just taken it a common. Okay, minus and plus that is now. 2I I have just taken it a common as a common term. Next we can see here plus term is there, therefore I am just taking it as first sin U alpha upon U square plus. Next I am writing this term, that is alpha into cos U alpha upon U. Alpha minus alpha into cos U alpha upon U. This is nothing but our required Fourier transform for the function x and 0. But here we have, by taking x, we have found the Fourier transform, and this is the required answer.